Yes. So now my screen is visible to all. Okay. So yeah, now we try some questions related to flip flop part. So I think it is better that we can start the questions part. Okay. Yeah. So like for example, I'm giving you the question. When GK puts over here, K is always one. This is a clock pulse. Q is the output. This is the okay. This is the circuit that is given. Now at clock zero, that means till no clock pulse is applied, we are assumed that JK flip flop is reset. Okay, reset. What is the meaning of reset? That output Q is zero. Okay. Now we have to find out what is the clock output at the clock pulse. Okay, we have to find out output Q as a clock pulse. This is the first part. Second, we have to find out the sequence of Q till 6 clock. Okay, this is the question. Now, can you solve it? Can you solve it? Hello, am I audible? Okay. Yes, what is the output after 4 clock pulse?
Is it 01010?
Let's check. So when Q is 0, initially clock 0, so it is a 1. Okay, so here we are getting a 1. Okay, now when first clock pulse is applied, J and K both are 1. So I just mark J and K both are 1. Okay, when J and K both are 1, the output Qn plus 1 is Qn bar. So if Qn is 0, so Qn bar is 1. So that is 1. Okay, now this is 1, that means this is 0. 0 applied here. Now when clock pulse 2, J is 0, K is 1. When J is 0, K is 1, that means Qn plus 1 becomes 0. So output is 0. Okay, now again it is a 0. Here it is 1. Okay, so now J and K both are 1 1. Then again Qn plus 1 is Qn bar. This is the previous input for the next. Okay, so it is a 1. Again it is a 0 1. So it is a 0. Again it is a 1 1. Then 1. Again it is a 0 1 0. Okay. Hmm. So my question is, first question is that what is the output at fourth clock pulse? So the output at fourth clock pulse is 0. And what is the sequence of that one? So first clock pulse sequence 1 0 1 0. Okay.
I have a question. Like,
Yeah.
if we change it to SR latch, right?
Yeah.
JK flip flop to SR latch.
SR latch or SR flip flop?
Oh, SR flip flop. Sorry.
Yeah.
So will it work?
Will it work? So what is the basically combination is that if SR is 0 1. Okay, we consider that only two inputs are there, 0 1 or 1 1. Okay, so when it is a 0 1, so the output is 0, and when it is a 1 1, what is the output? Invalid state.
Yeah, it's invalid.
Okay, so that means we can't identify what is the output in this particular question, so we can't consider that it is a X.
Okay. Okay.
Okay,
Thanks. Yeah.
so is it clear how we solve this question? Now can I take one more questions? Hmm. Okay. To A, this is the A flip flop, D flip flop, QB, QB bar, to a bar, J, K, K is always 1, pulse. Okay. At clock 0, QB, QA both are 0. Okay. Or we can say the flip flop are reset. Okay, flip flop are reset. Flip flop are reset. That means QB is equal to QA is both are 0. Okay. So J, K, JB, KB, QB and QA. The question is after 5 clock pulse, QB and QA is. After 5 clock pulse, what is the QB and QA? Yes, what
Uh,
is the
i-
Q?
is it 1-1?
1 1. Yes, everyone.
So 0 1.
One answer is 1 1. One answer is 0 1. Next, any other? Okay, so let's we start that at clock 0, all flip flop are reset. So QB is reset. So QB is connected to KB. So KB is 0. Okay. QB bar is connected to JA. So that means JA is 1. K is already 1. Okay. JB is QA. QA is 0. So it is a 0. Okay. Now when we apply both filters 0, 0 because it is a initial condition. Now when clock 1, okay, J and K both are 1 1, so that means QA is toggle. So QA is 1. Okay, and what is QB? QB is remaining 0. Why? Because JB and KB both are 0. So it's remaining no change condition. Okay, now if QA is 1, so that means JB is 1 for the next. If QB is 0, so KB is 0. Okay. If QB is 0, QB bar is 1, that means JA is 1 and KA is 1. Now when we apply the clock second, so when both are 1 1, QA is again toggle, it is a 0, and when it is a JB, KB 1 0, 0 so it becomes 1. Okay, now if QA is 1, that means JB is 1. Sorry, QA is 0, so that means JB is 0. Okay, when QB is 1, KB is 1. Okay. When QB is 1, so QB bar is 0, so J is 0 and K is 1. Now when we apply the clock third, 0 1, that means JB is 0. 0 1, that means KB is 0. Okay. Now again, first state will be coming. This state will be coming when QB and QA both are 0, 0. So we are considering that this J is 1, K is 1, JB is 0, and KB is 0. Now again for the clock 4, so it becomes a 0 and 1. So again the repeated this particularly part is repeating. Again this one is repeating. So after 0 0, it's a 0 1. If it is a 0 1, so it becomes a 1 1 1 0. Okay. Now when it is a 1 1 1 0, so it becomes a 1 0. Clock 5, and it is a 0 1 0. Yes, now check. Is it correct? Any doubt?
Sir, after clock 0 means at the clock 1 means how do you found that QB and QA 0 1?
Wait a minute. If you are getting confused, so basically we don't know what is the value of JK, JB, and KB. So we are shifting at here. Now it is fine.
Okay.
Okay, we don't know what is the value of JK, JB, KB. So these value is not, we don't know. But we know that clock 0, it becomes a QA is 0 and QB is 0. Okay, it is given in the question. Okay, flip flop are reset. That means QA and QB both are 0. This is given in the question. Now, if it is a 0, 0, so when QB is 0, so it will be applied at a KB. So what is the value of KB? It is 0. Before clock applied. Okay, before a clock applied, KB is 0. QB bar is 1 because QB is 0, so QB bar is 1, so it will go to the J, so J. K is fixed, that is 1. And what is the JB? That is the connected with QA. So QA is 0, so that means KB is also, JB is also 0. Now when the clock pulse is applied, because of these two input, we are getting a QA. What is the meaning of QA? QA is that if J and K both are 1, 1, so QA will be toggle, so it becomes a 0 to 1. Okay, and when JB and KB are 0, 0, so it is a no change. So no change, that means 0, 0 remains 0. Clear?
Yes, sir. Yes, sir.
Okay, now on the basis of this one, we decide what is the JA, KA, JB and KB. That is before clock pulse. Okay, now when we clock pulse is applied with respect to this JB and KB, we are getting a QB. Okay, and because of JA and KA, we are getting a QA. Clear?
Yes, sir.
Question third. Clock. Clock. This is a Q. Q bar. Q bar connected to T. If we say the clock has a frequency of 100 hertz, okay, if we say the frequency of clock signal is 100 hertz, what is the frequency of output signal? What is the frequency of the output signal? Yes. What is the frequency?
What's the initial state of the flip flop?
The initial state we assume that if it is not given in the question, so we assume that flip flop are in reset condition.
Okay, okay. Thanks.
Yes, what is the frequency? So what we do here is that we just draw one clock signal. Okay, and so on. We just draw a 4 clock pulse. Initially, we assume what is the Q? Q is 0. Okay, when Q is 0, the Q bar is 1. So it will be go to the response bar. Now when T is 1, the output will be toggle. So initially it is 0, so it will go to the 1. Remain till this position. Okay. Now when Q is 1, Q bar is 0. When Q bar is 0, T is 0. So what T do? T will be remain at the same position. Okay. Now for the third clock, Q is 1, this is 0, 0 will be go to a T part. T part we say because T is 0, Q is same. So Q and plus 1 will be remain same. It will be remain same. Okay. So we can't identify the clock, the frequency of output. The frequency of output. Okay. Now we do one change. We just set it to as a T. Now what is the changes in that?
So won't the frequency be like 0 since the
We
time
can't
period
say
is
we
infinite?
can't say the frequency will be 0.
Like if you let the clock go on forever,
Mhm.
like 1 over time period, like time period is infinity.
So time period is infinity in that case. Uh, so in that case, we can say, but it is not a true, na. We can't say that, like for example, the clock is applied for 5 seconds, for 10 seconds. So we can't say that it is an infinite time period. Okay.
Okay, okay,
So that's why we can say that we can't identify.
okay.
Question 4. Q J is connected with Now, initially we assume that at clock 0, flip-flop are reset. Okay, so we don't know what is the value of J and K. We know the value of Q is here. Okay. Now after clock 6, what is the Q? Okay. First question. Second question is that if clock frequency is 1 megahertz, what is the output? What is the frequency of Q1? Let's do the second question. Yes, what is the output?
The frequency is 0.5, and
0.5 megahertz.
yes,
Okay.
and at clock 6 it's 0, I think.
Okay. And what about others? Anyone solve this one?
So same.
Same. So basically at clock 1, what is the J? If Q is 0, so J is 1 and K is 0. So we are getting 1. At clock 2, if it is a 1, so J is 0 and K is 1. So it is a 0. At clock 3, okay, so it is a 1 0 1. Clock 4, it is again 0 1 0. Clock 5, it is again 1 0 1, and clock 6 is 0 1 0. So at clock 6, what is the Q? Q is 0. Okay. Now if you see that, it will be repeat after 2 clock pulse. Okay, so the frequency is f by 2. So if 1 megahertz is the frequency, so here is the 1 by 2 megahertz is the frequency.
Hello, sir.
Yeah.
Have you taught time delay concept? Because I am little bit trouble in time delay concept.
Which concept?
Time delay, time setup, time hold, time delay.
M delay.
Yes, which is
Okay.
covered in like week 12.
Week 12.
Yes, sir.
You are asking about the Millet or M delay?
No, no, time delay, time delay. I will type in the
He's
again.
asking time delay, I think. The critical path delay, I think so.
He is saying the M delay.
Time delay. He
Okay,
just
okay, okay.
wrote it in the text.
Okay. So, okay, so we will go with the time delay path. Using a simple circuit or some other like,
Like two flip flop and the combination circuit with it.
okay. So,
I have a question also if you allow me to.
yeah, you can
I
share
will
your
do.
screen. You can share your screen.
Give me a minute. I can say.
Are you going to share?
Uh, yes, sir. Give me 1 minute. Hello, sir.
Yes.
Can you see the question?
Yes. 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 Yes.
So there is one mistake. The ignore it also delay about
Mm-hmm.
9 nanosecond.
Okay.
Sorry,
9 nanoseconds.
uh, two nanosecond.
Hold on a second. So wait a minute. I just draw this circuit.
In which TPR is a preset time and TH is hold the time and TDF is a uh, flip-flop delay.
Wait a minute. We are using Q0 as a D1. Q0, D1, this one, and this one. Yeah, then no. That is Q0. So first Q1. Okay, now TPR 3TN. TPR is 3, TN is 1, and TDFF is 7 nanometer. Okay, and TPR is 3, TN is 1, TDFF is 616. 1. And XNOR will be 2 nanosecond.
Yes.
Okay. No. And what the TPR, TN, and TDF? This is the different from the generalized.
TPR is a preset time and TH.
Your voice is not clear. Your voice is not clear. What is the TPR? Propagation delay.
TPR is a preset time.
Preset time.
Preset,
TN is
no,
settling
not
time.
TN. It's a TH. It's a TH.
TH. H is the whole
Yes, sir.
time.
Whole time. And the TPR is a preset time.
Hmm. And TDFF is the flip-flop delay. Okay. So now what is the question in that one? Any question is that? Any
Yes,
statement
sir.
is that?
Maximum clock frequency or which sequential circuit work properly.
Okay, maximum clock frequency.
Yes, sir.
Okay. So if you see that, how much time it will be taken by the D flip-flop first?
First flip-flop.
Mhm. What is how much time it will be taken by the first flip-flop?
1 nanosecond.
Yes, Satindra, wait a minute. I just solve this question. So first flip-flop will be taken as a 11 nanosecond. Okay. What is the preset time? If this is my clock pulse, or if it is my changes. So we distribute this one into two parts. One is the before starting of this one, after the ending of this one, and then delay. Okay, so we distribute as a TPR, TH, and TDFF. Okay, so total time taken for the first flip flop to get the output is the 11 nanoseconds. Okay,
Yes, sir.
now in this 11 nanosecond, my second flip flop propagation delay, preset time will be covered. The hold time will be covered. After this 11 nanosecond, it will be taken as a 5 plus 1, 6 plus 6, 12 nanoseconds. So total time delay is the 23 nanoseconds. Okay, and this 23 time taken from this particularly point to this point. Now in between them, there are the 2 more nanosecond delay. So that means from this point to this point again reach back, it will be taken the 25 nanoseconds.
Sorry, sir. Sorry, sir. I not got it. Like, how the 23 nanosecond is come?
Yeah. 11 nanosecond will be taken by the first flip flop. Okay.
Yes, sir.
12 nanosecond will be taken by the second flip flop. So total time
But
delay is a
sir, it's a like sequential trigger, so it triggered like individually. So we
it
can consider like
triggered like individually. But what is the thing is that, like for example, if we are taking about the first clock first, okay, it will be this
okay,
particularly flip flop will be providing me the correct output after 11 nanosecond.
okay,
Yeah, but this flip flop will be providing me the output after first flop first. Why? Because it is a individually working. What it assume,
okay,
it consume, if it is a not a correct output, we assume that D is either 0 or 1. Okay, any state is possible. D1 either 0 or 1, doesn't matter. It is a correct or incorrect.
yes, sir, correct.
But when the correct output will be coming, the correct output will be coming as after 11 nanoseconds.
Okay,
Okay. Now after that, this particularly correct output will be considered the correct input for this one.
okay,
Okay. So that means the input coming, correct input coming at this point is after 11 nanoseconds.
okay,
Okay. Now this will be taken the again 12 nanosecond delay. So the correct output will be coming after a 23 nanoseconds. Okay.
okay,
Now this 23 nanosecond again it will be taken the 2 nanosecond delay, because first
mm,
input will be coming after 11 nanosecond. This input will be coming after 11 nanosecond. This input is also coming after 11 nanosecond, but doesn't mean it is a correct or incorrect. If we want a correct output, that means we have to wait till 23 nanosecond. But if we are not desired a correct output from here, we assume that after 11 nanosecond, this particularly flip flop will be giving me the output. Or why 11 nanosecond? At a 0, 1 nanosecond, it is also providing me the output. Okay. Like for example,
okay,
we are taking one case. Is that this is my one flip flop. I am taking only one flip flop. This is my DFF. Okay, I applied the D note. This is the Q note, and I am only taking the flip flop delay. TPD, propagation delay is 5 nanoseconds. Okay, that will be applied in a XOR. Okay, and that will be giving as a output remote where it will be the one. Okay, Now I explain with this way the exam with the waveform. So we are taking the flow. This is my clock pulse with a 1 nanosecond clock pulse. Okay, that means one clock pulse is the 1 nanosecond. So 1, here we are taking the 2, 3, 4, 5, 6, 7, 8 in this way. Clear? Now, what is the D naught? What is the D naught at t is equal to 0? We can't identify. We assume that initially Q is reset. That means Q is 0. Okay, initially Q is 0. So 0 is coming here. 1 is coming here. We are getting 1 here. Okay. So we are getting a 1 here. So if we draw the two table D, so we are getting a 1 here. Okay. Now, when 1 is applied at a first clock pulse, we are getting output with respect to this Q naught is after 6 nanoseconds. Why? Because it provides me the 5 nanosecond delay. Okay. So if at a 1 nanosecond, I provide an input, it will be achieved at a 6 nanosecond. Okay.
Yes, sir.
Now, till 6 nanosecond, this Q naught is again till 0, remains 0. Because we don't know what is the value of Q naught. We know the Q naught exact value which is dependent on D naught after a 6 nanosecond or after a 5 nanosecond. Okay. Until that, what we assume Q naught is 0. What we assume Q naught is 0. But what is the actually Q naught? Q naught will be 1. Why? Because D naught is 1, that means Q naught is 1. But this Q naught will be 1 at a 6 nanosecond. Till that, what we assume? We are assuming that Q naught is 0. Okay, if Q naught is 0, every time the D naught is 1. D is 1 and D is 1 is applied. Okay, after 6 nanosecond, we say that if we apply D as a 1 nanosecond, at a 1 nanosecond D is 1, so Q is 1. So Q is, we are getting a 1. After 6 nanosecond, with respect to this one, we are getting a 0. Okay, so after 6 nanosecond, we are saying that D naught is 0. Okay, after 7 nanosecond at D is equal to 2 nanosecond, it is a 1. So 1 is applied, 1 and 1, we are getting a 0. So after 7 nanosecond, we are getting a 0. After 8 nanosecond, at 3 nanosecond, we are getting a 1. Okay, so 1 and 1 XORing, it is a 0. So at 8 nanosecond, we are getting a 0. And so on. Okay.
Okay, sir.
Okay, so we are getting the output, but doesn't mean it is a correct output or incorrect output. If we are talking about the correct valid output, we have to wait till the propagation delay is over. Is it clear? So 11 nanosecond till 11 nanosecond, if we are saying that all particularly flip-flop are reset, so till 11 nanosecond D Q naught is 0 and Q naught is 0, so that means D1 is 1. Okay, but this is only the assumption that we are assuming that all flip-flop are reset condition. But what is the actual output that will be coming after 11 nanosecond? Okay, so this is the correct output after 11 nanosecond. Now this correct output goes to the input of this one D1. So at 11 nanosecond, we get the correct input for D1. Now again, if we are providing that 11 nanosecond delay here, after 11 nanosecond, if the input is applied, the input will be getting the output. It will be taken at 12 nanosecond. So the correct input is applied at 11 nanosecond, and correct output we are getting at 23 nanosecond. Okay. Now this 23 nanosecond and 2 nanosecond will be delay from here. So we are getting a total at 25 nanosecond. So the signal that we applied at a 0 nanosecond here, it will be getting back again at a 25 nanosecond. So this is the complete delay. Clear? Now with this particularly,
Yes, sir.
yes, now such a
So if we consider like a middle input combination, like if we suppose that like this combination, this sequential circuit work before working, then if we choose like middle condition,
what
if
is
we
the middle
suppose
condition?
like this circuit works previously, then
Mhm.
if we calculate it in the middle of,
So what is the effect of that one you are considering?
so we can calculate individually, like in the middle of the
But
working.
till the input is not appropriate, till the input is not appropriate, we can't say that the output you are getting is the correct. Okay. If you are saying like, for example, if I just change one thing is here in the circuit, is this particularly is not taking any this input is inducer. Now that is not dependent on the previous condition. Okay. Is it clear? Now one. Now if we now in this scenario, what will be happen? If we apply a clock pulse 0 at a 0 nanosecond here, we are getting the output at a 11 nanosecond. Similarly, if we apply the clock pulse at 0 nanosecond, because of this one, we are getting a delay as a 12 nanosecond. Okay, so one particularly input for the X NOR gate will be approaching at a 11 nanosecond, one will be approaching at a 12 nanosecond. Okay, so which one is the maximum? That will be the correct. Okay, so the 12 nanosecond will be the total input that is approaching. Again, 2 nanosecond will be taken by the X node. So we are getting a 14 nanosecond delay. You are asking this thing?
Yes, sir.
Just Sachendra, you are asking something? Are you available in the? Yes. Yes, good streak.
I have a doubt in practice assignment 12, question number 12.
Practice assignment 12, question number 12. Let me check. Can we do in the tomorrow class? That is better. Actually, I have to open it and then I have a class at 10:30 again.
I just have like one doubt. So I'm getting like 12.99 the frequency,
Okay.
but the answer says it's 12.5.
Okay.
Yeah, I think it might be an error because the critical path was giving me 77 nanoseconds. Yeah, I just thought like maybe someone asked it before. So yeah, we can do it in
Yeah, in the next
More
class we
session.
will do
Yeah.
that.
Okay. Yeah. No worries.
Yeah, actually I
Thanks.
have a class again. That's
Yeah.
why.
Yeah. No worries. Okay.
Uh, okay, so I think we stop here. Yeah, one more thing is that your Friday class will be rescheduled on a Wednesday. Okay, 8 to 10.
Sir, I had a doubt in this question.
Yeah.
What is this preset time?
Preset time is basically, we can say, the setup time before. Sometime it is called the preset, sometime it is called the setup time.
And
Okay,
what
you
is
hold.
TDIF?
T
DFF.
and DFF is the flip flop delay. The flip flop delay. That means after the holding, what is the time it will be taken to get the output?
Okay, so it is not the same thing
No, no,
like
no, 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 no. It is
TPD.
not the same. Not in the TPD. Yeah, TPD, propagation delay, is the completely delay. Like for example, if we are saying that my clock pulse is ideal, okay. Generally, what we are considering that my clock pulse is ideal. So that means the particularly clock pulse rising time goes from 0 to 1. It will be taken as zero delay.
Okay.
Okay, like for example, if I am saying this is my ideal clock pulse. Okay, this is my ideal clock pulse. So particularly ideal clock pulse will be taking no time for that going from the low to high level. So that's why we completely say that this is the PPD, propagation delay. Okay, but the thing is that if we go to the ideal practical scenario, so there is some transition time. So we distribute this transition time into three parts. One is the TPD setting type, hold time, and the D flip flop. Okay.
Okay, sir, got it.
So if you go with the hardware implementation, if you go with the particularly that one, so it is not possible that it will be not taking any time. You have to go from the level 1 to level 0, level 0 to level 1. So that's why we are talking a setup time, hold time, and propagation time. Basically flip flop time, delay time.
Is it same as TCQ, clock to Q?
Yeah, that is considerable for the clock pulse TCQ.
Because like
But sir, T setup, that is T preset here, it is taken before the clock is right.
Before, actually before the clock, when the clock will be going to from the low to high or high to low, so that time, so we are not considering that it will be the before the clock, but when the clock will be starting rising, so that's we are taking the TPR preset time.
But for in practical cases, the clock edge is taken to be from T low to high and the 50% of it,
Sometime
right?
it is at 50%, sometime it will be taken at 10 to 90%.
Okay, okay, okay. Got it, sir. Thank you.
So thank you all. Yeah, again, the announcement is that your class tomorrow, you have two class. One is the 2 to 3 and one is the 8 to 10. Okay.
Tomorrow we have two classes.
Yeah.
Okay. Mostly a revision session throughout
Yeah,
or
revision session, because I think all particular part will be covered. So only the revision session.
Mhm.
Okay, if you have any doubt, you can ask the questions. If we can solve some questions, if you have some problem, like for example, particularly weak, you have a problem, so we can say, we can take some more questions related to that one. Otherwise, we can go with the revision part.
Okay, okay.
Okay.
And any pathway to just prepare in this last few days there? Any guidance we'll be having on the
Mm,
not exactly the to the specific, just in general. You just last time you told that all for 1 week will be there, and 1 to 8 weeks something 50-50 and 9 to 12 something is 40-50% weightage and all that. But
Yeah, I think better is that you can mainly focus on from 9 to 12 because that particularly will be the around 50% part, 40%, 40% part of that.
right.
So the thing is that otherwise, do some more practices. When we are going with some more practices, I think you will better doubt clearance in that part.
Right. Okay. Oh.
Yes, Satyendra.
Hello.
Yes, Satyendra.
Sir, sometimes can I share my screen?
Yeah. Satyendra, actually, I have a class at 10:30. So can we do in tomorrow class?
Okay. Okay.
Okay.
Okay.
Thank you. Tomorrow we have a 2 class, so you just take your doubts, so we will go with the every doubts in that one. Okay. Thank you all.
Thank you, sir.